LEO, GEO, MEO satellites, what's the difference? Here at Simple Flying Connectivity, we frequently reference different types of satellites used for in-flight connectivity. While you may well know the meanings of the acronyms LEO, GEO and MEO, do you really understand the difference between them? Let's take a look to find out what makes these types of satellites different. GEO, geosynchronous equatorial orbit. These satellites, also sometimes called geostationary satellites, are probably the most widely recognized and most well-understood types of satellites. Because they move at the same velocity as the Earth and on a path that is parallel to the Earth's rotation, they appear to be stationary in the sky. This enables them to provide coverage to a specific area of the Earth. Orbiting at around 35,000 kilometers, 22,000 miles above the surface, geosatellites take precisely 24 hours to perform a complete orbit of the Earth. As the largest type of satellite and the extreme distance at which they orbit the Earth, only 3 geosatellites are required for complete communications coverage. Geosatellites have been around for over 50 years. The first was NASA's SYNCOM-3 experiment, which took place in 1964 and provided worldwide television coverage of the Olympic Games in Tokyo. As of December 2019, the UCS satellite database lists 562 geosatellites in orbit, but space isn't full yet. The ring around Earth can accommodate up to 1,800 geosatellites, so there's plenty of room for more. While GEO has been the tried and tested satellite for everything from television to essential government communications, it does have its downsides. These are the most expensive satellites to procure and, due to the curvature of the Earth, coverage cannot be provided above or below plus or minus 70 degrees latitude. MEO Medium Earth Orbit. MEO satellites orbit at a lower altitude than GEO, usually occupying the space between 5,000 and 12,000 kilometers, 3,100 to 7,500 miles. Their relative proximity to Earth means they achieve far lower latency than GEO units, making them suitable for high-speed telephone signals and similar missions. MEO satellites can transmit data at up to 1.6 Gbps, which is a much snappier connection than most of us achieve through fiber connections to our homes. These types of satellites are also used for functions such as GPS, GLONASS and Galileo, as well as in polar orbit to provide coverage at extreme latitudes. Depending on their altitude, MEO satellites usually complete one orbit of the Earth in between 2 and 8 hours, although some can take up to 24 hours to orbit. Their smaller size and lower orbit means between 8 and 20 units will be required to provide complete coverage of the Earth. LEO Low Earth Orbit. One of the hot topics right now is the race to establish a network of low Earth orbit satellites. LEO satellites occupy the lowest orbit of all satellite types, often between 800 to 1,600 km, 500 to 1,000 miles above the surface. This proximity to Earth makes them ideal for very high-speed, low-latency communications, often exhibiting a delay of just 0.05 seconds. LEO satellites tend to be very small, making them much quicker and cheaper to produce than their bigger brothers. They also fly much faster, completing an orbit in as little as 40 to 100 minutes. However, their proximity to Earth means many more are needed to provide complete global coverage. Companies like SpaceX and Iridium are planning to put tens of thousands of LEO satellites into orbit over the next months and years. These huge mega constellations are likely to provide faster, more stable and more complete coverage for data connections in the future, but are still at an early stage in terms of network development.